Hi there,
It's Mrs. Flynn.
and Mr. Rops. We're working on volume and surface area. We're talking the volume of a cuboid is 125 centimeters cubed.
All right, well, first we have to know what a cuboid is.
Ooh, it reminds me of the board in Star Trek. Do you ever see that?
No.
I'm showing my
Star
age.
Trek, no.
Sorry. Okay, sorry. A cuboid is just what we call a cube.
Yeah.
So all the sides are the same.
So, I don't know, we can start off by, since it's telling us that the volume, we could write the equation for our volume of a cube. It's area base times height.
Sweet. Well, we know that the area base is like side times side, and the height is also the same as that side.
Yeah. So, can I just call it x this time?
Sure.
X times x times x, which is
X cubed. Sweet.
And if we know that the volume is 125 centimeters cubed, substitute that in.
Mm-hmm.
And a couple different ways we can do this. Maybe we already know our cubes. We know that 5 times 5 times 5 is 125.
All right.
Or another thing we could do is take the cube root of it.
All right. And our calculator will do that for us.
So I'll just show you really quick here. We can go to math, and number 4, and then type in 125. And it gives you 5.
Right, so x is 5. So the length of our side of our cuboid is 5. Now we need to find the surface area of the cube. Well, the surface area, if we remember, is just, there's 6 faces and they're all x times x. So x squared. And so we plug our 5 in, times 5 squared.
And we get all together 6 sets of 25, which is 150.
150. And our unit,
I better label that.
of course, is centimeters squared, because we're down to area. Super. All right, let's hammer out one more example there. Okay, so a double cone is inscribed in the cylinder shown. 2 identical cones upside down inside the cylinder. The surface area of the base is 49 pi centimeters squared. So one of those blue things are 49 centimeters squared.
Just go ahead and write that in. Surface area equals.
Nice. The height of the cylinder is equal to the diameter of the base.
Ooh. The height.
Right.
Let's call that x. Oh.
Okay.
Is equal to the diameter
of the base.
Or I could say this is a base as well, so
right.
X.
Okay, so find the volume of the space inside the cylinder, but outside the double cones.
Ooh. Inside the cylinder, but outside the double cones.
Right. So it's kind of like an hourglass kind of scenario, where the sand is inside those double cones, and the air is all in the glass area between the hourglass things, if that makes any sense. Okay, so in order to do this, we need to find, I think we need to find the radius.
Okay, well, given that the surface area of the base
is 49 pi.
Well, we could easily find the radius from that.
Right.
Because this shape here is a circle.
Super.
And we know that the area of a circle is
pi r squared.
So let's just go ahead and substitute. Now, this is a big question that's asked a lot. Surface area and area. Well, they're the same.
Mm-hmm.
So this is 49 pi equals pi r squared. To isolate our variable, divide by pi. Oops. 49 is r squared, and we already know our perfect squares. R can't be negative, so
we get
positive.
7. Okay, so there's our radius. So does that help us with other things?
It does, because now I know that x is going to be
twice the radius, which is 14. Yeah. The diameter is 14. All right, well, that's good.
Okay.
Well, so what's the height of one of those cones going to be then?
Ooh, that's a good question. This is their height here.
If they're both identical,
then they got to be split in half.
Right. All right.
This has got to be 7.
Got to be 7. All right. So to do this problem, maybe we should find the volume of the whole entire cylinder, and then of one of those cones.
Okay, so let's see. We'll start off with the cylinder. Volume of a cylinder. Volume equals?
Pi r squared h.
area of the base times the height.
You're
Area
right.
of the base
Times the height.
Okay, we already know that the base has the area of,
49 pi.
and our height is,
14.
all right, so the total volume, let's use our calculator. Do we want to keep it in pi form?
Let's keep it in pi form.
Okay, 49 times 14. When we keep it in pi form, it's exact.
Yep, I'm a big fan of exact values.
There we go. That's the volume of the cylinder.
All right.
But we're not done there.
No, we need to find the volume of one of those cones.
If we find the volume of one cone, then we can just double it. So
Okay.
let's see. Volume of a cone is 1/3
Area of the base
pi r squared.
times the height.
All right. So let's see. 1/3, we already know the area of our base is.
All right. 49 pi.
And the height, we have to be careful here because we're just doing the height of this small cone.
All right. I wasn't going to see that.
So that's times 7.
All right.
Again, leaving this in exact form. 49 times 7 divided by 3. Yeah. Okay.
Let's change it to a fraction. Let's do that.
Okay.
You know how to do that with your
Oh, no,
calculator?
no, you.
Go math. And number 1 is fraction. Hit enter.
Ah, fancy.
And enter. It'll take your answer, put it in fraction. So
Oh,
343 over 3.
All right.
And so you can do that trick on your calculator and you convince your teacher that you really know how to do fractions. It's a good trick. All right.
All right. So now we have the volume of cone and the volume of a cylinder.
Okay, so now we have 2 cones, though, that we have to consider. So the total volume between the two is going to be the volume of the cylinder minus 2 cones.
Okay. Now let's just substitute in what we know.
Right?
Cylinder is
686 pi,
and minus 2 times
343
all over 3 pi.
pi.
Okay, so I have 686 pi. Clean this up a little bit by multiplying by, oops, just double it.
Oh, I can know that. That's 686.
Oh, yeah, I should know that too, huh? Minus 686 over 3 pi. Okay,
Adding our fractions.
common denominator.
Yes. So we have to put this one over 3.
Yeah,
Six,
know that
eight,
one in your
no,
head?
I don't know that one in my head. Oh, I better clear that one off, though. 686 times 3. It's going to end with an 8. 2058.
Pi minus 686 over 3 pi. So let's just minus 686.
So 1372 over 3 pi.
pi.
I wonder if that divides nicely by 3.
Let's see.
No, not nicely.
Let's change it to fraction.
All right, that's a good trick. Whoever taught you that, really smart. It's
Dang,
already
it's the same
reduced.
thing.
Okay. So what is our units, though? If we go back up to the top of the page, we can see that it was centimeters squared.
So this will be centimeters cubed.
All right, great. And now, believe it or not, that's a famous problem.
Ooh.
I forget the details, but it's historical and famous. So if anyone wants to find out about it, let us know.